This naturalrefrigerants.com article is being read by an automated voice. Part 1. Fenagy's Hydrocarbon Heat Pumps. Keep Data Centers Cool and Reuse Waste Heat by Michael Hines. Published April 21st, 2026. This is an excerpt from an article featured in Atmosphere's Clean Cooling for Data Centers 2025 report, which can be downloaded here. Atmosphere is the publisher of naturalrefrigerants.com. Fenagy is a Danish manufacturer of industrial heating and cooling systems, headquartered near Aarhus. Established in 2020, the company primarily develops heat pumps for the energy sector, with a strong emphasis on heat recovery and integrating natural refrigerants into large-scale applications, such as district heating and industrial processing. Initially focused on CO2-based solutions, Fenagy has since expanded its portfolio to include isobutane and propane systems in an effort to target a wider range of applications, including data centers. Fenagy is partially owned by Swedish manufacturer and wholesaler Beijer Ref. Fenagy largely views data centers as valuable sources of recoverable heat that can be reused for commercial or industrial scale heating. We want data centers to be located nearby big cities where you also have consumers who can benefit from the heat, explained Klaus Hoberg Jensen, Sales Director of Industrial Refrigeration and Heating at Fenagy. We want data centers to have this perspective in mind when they are choosing a location, especially the hyperscale data centers. The advantages of isobutane. The company designs modular heat pump chiller systems that can cool server rooms via water glycol loops while recovering waste heat and lifting it from around 30 degrees Celsius, 86 degrees Fahrenheit, up to 80 to 95 degrees Celsius, 176 to 203 degrees Fahrenheit, which is suitable for integration into district heating grids or local industrial processes. From the beginning, we knew that CO2 was not the ideal refrigerant for all applications, especially data centers, noted Hoberg Jensen. Around 2 years ago, we introduced isobutane, which can be used for several applications, but one of the most important is data centers. For combined cooling and heating applications, Fenagy promotes isobutane as the ideal refrigerant because of its efficiency and ability to deliver high supply temperatures regardless of return temperatures, unlike CO2. The company's HCI range offers heating capacities from 500 kilowatts, 142 tons of refrigeration, to 6 megawatts, 1,706 tons of refrigeration per unit, with supply temperatures of up to 95 degrees Celsius. Where there is limited local demand for heating, Fenagy offers propane-based chillers as an alternative. Its HCP range delivers temperatures up to 75 degrees Celsius, 167 degrees Fahrenheit, with heating capacities of 500 kilowatts to 6 megawatts per unit. For both the HCY and HCP, the cooling capacity is based on the heat source temperature. Both product lines are designed for water-to-water systems to ensure minimal refrigerant charge, according to the manufacturer. Beyond environmental benefits, isobutane offers strong thermodynamic performance compared to HFCs and HFOs. Even if we take off the green cap, isobutane is a better refrigerant, Hoberg Jensen explained. It can deliver warmer water for district heating at a competitive cost level. That's probably our biggest advantage with our HCI and HCP units. We are competitive on simply commercial terms against HFCs and HFOs. The modular approach. Fenagy's modular approach is particularly advantageous for colocation data centers, which rarely operate at full capacity upon opening, with server loads that grow over time. Fenagy's systems can start as small as 500 kilowatts of cooling capacity and scale up in line with demand, ensuring efficient operation at both partial and full loads. When a data center is built, it may only require 1 megawatt, 284 tons of refrigeration, of cooling capacity, he added. A 30 megawatt, 8,530 tons of refrigeration ammonia system would not be able to operate efficiently at such a low load. They would have to build many smaller ammonia systems, which is not the way it is done. Here is where we have a competitive advantage. While the systems are effective in a wide range of climates, most of Fenagy's projects to date have been in Northern Europe, where demand for waste heat is strongest.